We talked about scalar line integrals. Now we're going to deal with a vector line integral. And the definition I have there in blue is talking about what the vector line integral is. It's over a field f. So you're going to take the integral of f and have the dot product with whatever your other part is going to be. So we're going to actually use this formula down here. So the integral of with our smooth curve C of f dot t of ds we're going to take, and we'll have the field. There's the field part there, and then we'll have this within it here. So r of t dot r prime of t. So r of t is that. So each individual, and the problem I'm going to do below 52 doesn't require z. It's just going to be 2 variable instead of 3, but this is the general form for 3. And the derivative is just each individual one. However we do the reparameterization, we'll take the derivative of each one accordingly, and then take the dot product of that to find it. So let's try to do this problem number 52 here. So the field given there is yi plus 2xj, but we've got these points here, 1, 0, and 0, 1. So again, this is just 2 variables. It's a path from these 2 points. So we're looking at just a slope and a line. So our m is equal to 1 minus 0 over 0 minus 1, which is negative 1. I'll use the first point. So y minus 0 is equal to negative 1 times the quantity x minus 1. We're going from 1, 0. So y is equal to negative x plus 1. Okay, so to change the parameter, if we let t equal negative x, that means that x is equal to negative t. And if we plug that in to the other, then we have y equals negative t plus 1, which means that y equals t plus 1. So our rt is going to equal negative t and then t plus 1, which means that our prime t, if we just take the derivative of each one, the derivative of negative t is negative 1, the derivative of t plus 1 is 1. So that's what we've got for that. We need to calculate where r can be. So if we can choose either one of the, I guess t, not r. So solve to determine the values that t can take. Choose either one. I'll choose the x values, and I'll look at the x values here. They go from 1 to 0. So for x equals 1, I have 1 equals negative t, which means t is equal to negative 1. That's our lower. For x equals 0, 0 equals negative t, which means that t equals 0, which means we're going from negative 1 to 0. And that's how we're going to integrate. So we have this formula here. We're dealing with work, so we'll use W. That's going to be this F. So we can use the function, the field, excuse me. So we've got our yi, so our first part is going to be the y. And so let's, y here is x plus 1, t plus 1, excuse me. And this goes from negative 1 to 0. All right, so we've got t plus 1. And then we've got 2x for our j component. So x is negative t, so that's 2 times negative t. And then we need r prime of t. R prime of t is negative 1, 1. All of that dt. So that should be how we have it set up. We'll take the dot product of these two. Put the little dot there. Maybe a bigger dot. There we go. So let's see. So that's negative t minus 1 plus, excuse me, plus looks like negative 2t times 1, so plus negative 2t. Okay, again, we need a dot product, which is why we're going to add these to get a number. So it looks like so negative 3t and negative 1. Okay, so now we need to integrate. No, I don't need that because I'm going to integrate right now. So the integral of negative 3t is equal to negative 3 halves t squared. And the integral of negative 1 is just negative t. All of this is evaluated negative 1 to 0. Remember, the 0 goes first, so we're going to kill that. So it's 0 minus this next part. So negative 3 halves, negative 1 squared, and then minus a negative 1. So this is going to be negative. This is going to be negative 3 halves because the negative 1 will square to be 1. This is plus 1. All right, so that means we have negative 1/2 times negative 1, which should just be 1/2. So this is negative 1/2, which is just 1/2. And this is our work. So work equals 1/2, whatever the units would be.